Hi everybody, welcome to another video in Business Calculus, section 10.2, derivatives of exponential and logarithmic functions. Derivative of exponential function. Now we just focus on e to the x. So derivative of e to the x is e to the x. So it is the only function where derivative is itself. And notice that we talk about e to the x, and x to the e is completely different things. This is the power rule. Remember, e is a constant, right? So derivative of x to the constant, we take the constant outside and the original power minus 1. So that is the power rule. The exponential rule is derivative of e to the x is e to the x itself. So the only function of its kind. Right. That's why derivative of this function here. All right. So f of x equal to that. Now let's take a look. We have derivative of e. Okay, that's the very bad way to do. So we have the function. So we say derivative is equal to. It is not the function. If you write the function equal to that, then you write the derivative, it will be wrong. So we have something signal that this is the derivative. Right. So e to the x, derivative of that, it itself. And x to the fourth derivative is 3. Take the fourth down. Just talking about the derivative of x to the fourth is 4x cubed. Right? And then we have a constant 5. Constant 3 times it. And derivative of a constant is 0. Right, so give us 5e to the x. 3 times 4 is 12. X cubed. Right, that's simple enough. Next we have derivative of this function. Right, now x to the e. Not e to the x. This is not exponential function. This is just a power rule. So we take down the power and original power minus 1. Right, so that is derivative power rule. Then e to the x, we take derivative. Derivative of e to the x is itself, the only function of that kind. And then e cubed, well, there's no x in that. That means it is a constant. Because it doesn't matter what x is. There's e to the third is still e to the third. There's no x in it. The derivative of a constant is 0. So derivative of e cubed is going to be 0. Not even write that out. And then we have this. And yeah, that's pretty much the answer. Yeah. Right. Now check the derivative of this. Now we have to use some trickery here, because we know derivative of e to the x. This is x plus 1. Well, that's not gonna work out perfectly. If it is e to the x, then yes, derivative of e to the x is e to the x, but there's plus 1 on the exponent. So what can we do here? Well, there's some properties of exponents. I'll write them out here. Right. That would be e to the n plus n. Doesn't run out of ink. And if we divide, we subtract power raised to another power. Because we review this in the power rule. Right. So what we see here, actually it's not from left to right, but from right to left. And from here we can rewrite this remember I rewrite e to the x plus I rewrite it, haven't applied any derivative, but e to the x plus 1 is going to be e to the x times e to the first, right? So when we multiply, we add the exponent, so that's why we write like that, right? Again, haven't done any derivative yet, so that's still equal to the original function. E to the first power is e, so that's just 2e and then e to the x. Now notice that if you consider 2e and then e to the x and put a dot there, e to the x, we know derivative 2 times e is just a constant, so we have a constant times e to the x, and derivative of e to the x is e to the x, and then we still just have 2 times e. And multiply to it. And you say, wait a minute, is e is the same as e to the first? Yes, it is. But isn't that multiply is where we add the exponent? Yes, it is. So of course it's just x plus 1, so this is exactly like the original function, right? But we cannot assume like that, and we cannot assume that it's going to be the same function. If this is e to the 5x plus 1, then that will be completely different. It just happened to be just x plus 1, so still fine. However, the point I try to make is we can only take the derivative of e to the x. If there's something other than that, we have to do something else to get around it. In section 10.4, there is a way we can approach the problem directly, but here we don't know that yet, so we kind of have to go around and to get to e to the x where we can find the derivative of that. Right. More on this just in this section, and then more example later. Right. Next we go to the logarithmic function, in particular the natural log. Logarithmic function. Recall that the logarithmic function is an inverse function of exponential function. So we have y equal to log base b of x is equivalent to x equal to b to the y power, and b is positive and not equal to 1. So because there are, when we say inverse function, we mean log base b of b to the x is equal to x, or and b to the log base b of x is equal to x, right? And then we have the properties of logarithms from the product to a plus, quotient, subtract, and we can take out the power. Pretty much very similar to what we have here, right? Right, so like I said, this should be a review because this material is covered in business math. Now we focus on the calculus part of it, which is what is derivative of natural log of x. By the way, I just want to mention one thing quickly. Let's say if we want to graph the function e to the x, it will go like this. And now we graph the inverse function ln of x. It will go like that. And so the graph of exponential function, and this is the graph of logarithmic function. They are symmetric on the line y equal to x because they are inverse of each other. Let me change the parent. The parent of the line right. So we have exponential function and then logarithmic function, and they are symmetric on the line, log on the line here. Right. One more thing, again, it's just a review. When we write log without the base, we assume that base 10 and this is called the common log. So that button log is the common log base 10. ln of x is called the natural log, which is the log base e. Right. Now first we study about the derivative of the log base e, or ln of x. Derivative of ln of x is 1 over x, or simply we just say it, just write like that. Right. Now just more rules of derivative, but just derivative we can apply to each individual terms, and then we combine those terms. Right. We have e to the x. Derivative of e to the x is e to the x. Derivative of ln of x is 1 over x. And there's a 3 times plus 5 times. That's it, pretty much. Just cosmetic. We can multiply the 5 on the top. But that's all we have. Right. Next. Easy. Derivative of x to the 4th is 4x cubed. That power rule, right? ln of x cubed. So what is that? Remember, we only have derivative of ln of x. The 3 here is on the way. By the way, the 3 there should be ln of x cubed like this, right? So x cubed, certainly we cannot say it is 1 over x cubed. That would be wrong. So what can we do here? Right. So again, if it is ln of x, we know derivative. If it is ln of something else, we have to go around it, and certainly the way to go around that is, what if we have the log of something to the power? We can take the power outside. Now we write the equivalent formula ln of, let's say, that to some power. We can take the power outside. Right. Remember, that is not the derivative rule. That is the properties of the log. So, meaning that I don't apply the derivative rule here yet. So I just have to rewrite this as x to the 4th minus, what I do is I can take out the 3 on the outside. And then we have ln of x. Then we can apply the derivative. X to the 4th is 4x cubed. And the derivative of ln of x is 1 over x. So this is just my 3 1 times 1 over x. So 4x cubed my 3 over x. Right. Next we have this problem. Once again, if it is ln of x, derivative is 1 over x. We have that. That will be easy. Now this is ln of something. So once again, we have to go around it and get back to ln of x only. Right, so the way we do that is using the properties. Something we have to split the terms in the argument of the log. So we, in the ln, or log of any base, in this case just ln, so ln of m plus ln of n. Right. So yeah, this work for any base, and we just choose base e, and log base e is ln, natural log. Right, so we use that and we split ln of 4 plus ln of x. Remember, this is not derivative, so we just rewrite the function. We haven't done anything yet. By anything, I mean any derivative yet until now. Now we take derivative. Derivative of ln of 4, that's a constant because there's no x in it, so derivative of that is 0. Derivative of ln of x is 1 over x. Derivative of x to the e, not e to the x, x to the e, so this is just power rule, right? So we have 1 over x minus 3e times x to the e minus 1, right? So just like exponential function, derivative of e to the x only, or derivative of ln of x only. If there's something else in the argument, we have to go around it, get back to ln of x and e to the x where we can take derivative. I mentioned that before. In section 10.4, we can just go directly to it without going around it. But for now, I think those exercises are good practice of using the properties of the exponents and logarithms. Right, so that is for e to the x and ln of x. Now what happens if we have something other than e? For example, 2 to the x power, 3 to the x power. What happens if it's just any base? Well, if it is any base, the price we have to do to pay is ln of b and then still b to the x. So now we focus on derivative of anything raised to the x power is going to be equal to ln of the base times b to the x. Then we say, what happens if it is e? Well, can we use that? The answer is yes. Now if we use this formula, derivative is ln of the base and then the same thing, right? So in general it works like that. And then ln of e, we talked about that earlier. Ln of e is equal to 1. So this is just e to the x, right? So in general, anything to the x power, derivative of that is ln of the base times the original exponent. And if it is base e, then that will cancel out and we have 1. Right. So that will work for any base on the exponent on the exponential function. Now we go to logarithmic rules. So we have ln of x, or the natural log, is 1 over x. What happens if we have the log of different base? Well, the only thing we do that is still 1 over x, but we put ln of the base at the bottom, right? So where is that coming from? How do we prove that? So to prove that, we have one properties. This is called the chain of bases formula. Let me write that out in the note. Chain of bases formula. So we can go from any base to any other base. We can say log base a right. So any base of the argument divided by the same base of the base, the original base, right? Now, of course, if we can choose any base, why don't we just use ln? If we choose a to be base e, then we just have this. Or we can use the common log, base 10, and we have that, right? So that's what we have. Now, if we have y equal to log of any base b of x, I will rewrite as ln of x over ln of b, and I will rewrite this as 1 over ln of b times ln of x. Then we can take derivative. Derivative of ln of x is 1 over x. 1 over ln of b, just a constant. And multiply straight across, we have 1 over ln of b times x. Right, so that's the proof. Bottom line is, if the base is not e, we have to have ln of b somewhere. For exponential, it's multiply. For logarithm, it is divide. But bottom line is, those are the rules of derivative, and we just follow the rule, and that could be easy, right? Now, find the derivative. Here we have a lot of examples here. So, derivative 2 to the x. Now 2 is not e. If it is e to the x, derivative is e to the x is e to the x. Now there's a base 2. That means we're going to have times ln with the base. And then we just have the exponential term. 3 to the x, still ln of the base. And then exponential term, and then just subtract. That's it. Right, next we have ln log base 5 of x minus 4 times 3 to the x minus 2 times e to the 7th power. Right, now we take derivative. Now this is log base 5 of x. Notice that this is one term, and this is another term, and this is another term, so there are 3 terms here. Log base 5 of x. Well, it's going to be 1 over x, and then we multiply by ln natural log of the base. So that's the derivative of that term. And then 3 to the x, derivative of course ln of 3, and then 3 to the x. There's a minus 4 constant coefficient. E to e to 7, there's no x here, so it's just a constant. Derivative of constant is 0, so that's all we have. So have 1 over ln of 5 times x minus 4 ln of 3 to the x power. Yeah, so I said the rules are very clear for the derivative of the logarithm and the exponential function. It will just stay exactly to that. It should be easy. Alright, now we have derivative of any log of any base of x. This is something else, so we have to take care of the 4 from time. Take care of the 4 first, and we can only take derivative of the log of x, right? This term though, no x in it, so once again it's just a constant. So I write a little note here. This is constant. Derivative of constant is equal to 0. Same thing here. So that term doesn't really do anything in the derivative. It's going to be 0. Right, so we need to take out the 4 on the exponent. So the way we do that is we can move the exponent outside. So we'll rewrite as 4 times log base 3 of x and minus log base 3 of e. Right. Now, let's just write the formula that we use. Logs of any base of m to the power p. We can move the p outside. So that's what we have. Now we take derivative. Again, that constant will be 0. Derivative of log base 3 of x is going to be 1 over ln of 3 times x. And we can multiply the 4 on top. 4 over ln natural log of 3 times x. Right. Once again, we can take the derivative of e to the x, or any base to the x, or ln of x, or log of any base of x, but it have to be x. If it's something else, we have to simplify first using the properties of the log or property of exponent just to get x, so we can take the derivative. Right. Here we have log base 2. It is for the whole term like this. Right. So we need to take a break it down. If it's just x, then we can do that. Well, first, this is divide. So there will be a difference. A difference. And now this is multiplying. So it will be addition. Once again, what's that? Okay. This is the formula that we use in here to simplify the logs before we do the derivative. So multiply, we add still base 2 square root of x minus log base 2 of 5. Right, that's good. And we said, yeah, not to that constant derivative of that is doesn't matter, but we have the square root here. So what can we do with the square root there? Well, because we need to have log of x, then we can take derivative. So square of x is in the way, so we have to rewrite square root. Remember, we did this in where we learned about derivative of power rule. Square root is equivalent to the 1/2 power minus log base 2 of 5, and exponent moved outside. So log base 2 of 3 plus 1/2 log base 2 of x minus log base 2 of 5. Remember, all of these are equal. I haven't applied any derivative yet. But now we can take derivative of log of x, right? That's what we need to do, all of this. Right. This is constant, so derivative is equal to 0. Derivative of this is equal to 0. So that easy. We just have derivative of the log there. So that is straightforward after we do all of this. Now we have 1/2. Mean derivative of this is 0, 0. So that doesn't really do anything. Now we have the log base 2 of x. Derivative is 1 over ln of the base 2 times x. So multiply straight across, we have 1 over 2 ln of 2 times x. Yeah, just like that. Right. Next we have exponential. Again, if e to the x, that's easy. But it is e of ln of x plus 5, so there's a lot of things that we need to clean up before it. Remember, if it is e to the x, then yeah, or ln of x, yes, but a lot of work need to be done here. Right. So first thing we see is e to the something plus something, so we can split like this. Right, and once again the properties that we use, I'm just going to say it, write it in backward. Right, now what's that? We mentioned earlier logarithmic function and exponential function, if the base are the same, are inverse of each other. So we have log base b of b to the x is x, and b to the log base b of x is x. So in this particular, e to ln of x is equal to just x. Or remember, on the previous section we say ln of e to the x is equal to x, right? Ln and e cancel out in this form and cancel out in that form as well. So this turned out to be just x. So we have e to the 5 power, which is a constant because there's no x in it, times x. Yeah. It turned out to be very nice. So derivative of x, that's power rule, x to the first derivative of x is 1. So we just have e to the 5th power. Right, derivative of x is 1. Right? Right. And now this. So once again, we have e to the x, any base to the x, ln of x, log of any base of x, but it have to be x. If it is something else, we have to go around it to get back to x, then we can take derivative. So the way we go around, if notice there is a difference here, so we can say if it is a difference, it's going to be b to m or b to the n. So we can split, and that becomes 3 to the x divided by 3 to the second. 3 squared is 9. Instead of write like this, we can write as 1 over 9, the constant, times 3 to the x power, right? Now it will be easy. Derivative, it's easy because now we have something to the x power. So derivative of 3 to the x is ln of 3 times 3 to the x, right? In the general log, of course, we have the exact problem earlier. Right, now we just have 1 over 9 as a constant multiplied to it, and that's pretty much it. If we want to, we can say ln of 3 times 1 on the top. We say ln of 3 over 9 times 3 to the x. We cannot cancel anything, and that as far we go. So as far as the rules for derivative of the log and exponential, is very straightforward. Derivative of e to the x is e to the x itself. Derivative of another base to the x is ln of that base times the same term as original 1. Derivative of ln of x is 1 over x. If we have other base, then we have to multiply by ln of that base at the bottom. The rule is simple. Things get complicated when we have to go around and get back to just that term. So there are a lot of rules that we need. Good news is in section 10.4, even though if we don't know all of the rules here, we still be able to do that and get direct to the answer. But it's always easier if we know more rules of the log and exponential function. The more we know about the exponentials and logarithmic properties, the easier we do the derivative. But that's all I want to cover in this section. As always, thank you for watching and see you in another video in business calculus.